Hi, my name is Kyle Niven, and this is Group 1's Lab 5 project here. I'm going to show you how to go through XFLR5 to do what we need to do for this Lab 5 project. So everything is pre-populated right now just to save time because these analyses can take pretty long. So let's get into it here, but I'll show you step by step on how to get it all done. So first thing we need to do is to create the airfoils here in the system. So I've got XFLR5 up. First thing you need to do is go to Direct Foil Design. And then we need to click Foils here and then Naka Foils. And then we need to add in our 4-digit Naka number here. So we have 0012 and 4412. Um, you can change the panels here, but you really need to change them later. So normally you would hit OK here. I'm going to hit cancel since I already have it all pre-populated and I won't lose any of the data that I already have. So, but once you click that, it's going to populate the actual foils in here. And then what you need to do is you need to right click on each of these foils and change, refine globally for each of these. You need to change the amount of panels you have. Normally it's between 200 and 150 is a good amount to make sure that all your data is converging and accurate. So for the 0012, I did 180, and then you would just hit apply and OK. Again, I'm going to hit discard because it needs to keep all the data that I already have. But for the 0012, I have 180 on that, and the 4412, I have 200 on that. I found actually at 200, the 0012 doesn't converge at certain points. So, but that is what I've got. So from there, you need to hit modules again and go to the XFoil direct analysis here. Like I said, populate or all the data is already populated, but normally this would come up blank here. But from there, you would have at least the Naka 0012 and the 4412 here showing up. What you need to do is to define an analysis. So you need to click analysis, define an analysis for each one of these. And we're using two different Reynolds numbers because one is at 60 hertz and one's at 30 hertz. So you would just put in your Reynolds number here. Mach number, we're going to leave it 0. You could put it in here, but sometimes you'll have issues with convergence if you add that Mach number in. So we're just going to leave it here at Reynolds number. This is the higher velocity, so higher frequency, so 9708. Lower velocity, the Reynolds number is 47301. So, but then you define your analysis here, and you hit OK, and then it would pull up an analysis here, and it wouldn't have any information in it. Then we need to go for, we're doing this from -8 to 24 degrees of angle of attack. So what I've found is that if you go, and what I've seen in some of the guides for this, if you start from 0 and then go to the number that you want, it would be it's better off. It's if you just go from -8 all the way to 24, it tends to sometimes get a little weird around 0. So, but you would run an analysis from 0 to 24, and then you hit analyze. It needs to be a sequence, initialize boundary layer, and then store op here. So, and then it would run through the actual data, and then it's going to populate these graphs here. So you would need to do that for the 47,000 and the 97,000. So I have them highlighted in brighter colors. So you do that for 0 to 24. Then also from 0 to -8, if you run that, it's going to run. If it has an error, it's going to keep the window up and tell you what it's not converging at. So that's when you can play around with the actual panels that you have on the airfoils to make sure it converges. So, but then you run that for 47 and 97, and then you're going to populate all these graphs here. They're going to just be a generic graph to start, and then you can define which axes you need. So if you double click on them, they bring up your y-axis and your x-axis selections. So for this one, we needed CLCD or CL versus CD. We also needed CL versus alpha, and you can do it for all 5 of these graphs. We only needed 4, so I have those there. But CL versus alpha, CD versus alpha, and CLCD versus alpha. So we get all those, and then you can see the 4 runs here for both Reynolds numbers and then both airfoils that we're doing. So that being said, that's the first portion of it, and that is only for the airfoils here. Then we need to move on to the actual wing analysis. So to do the wing analysis, this is where all of these analysis come in on that. But we need to create a batch analysis for it to use to process the wing analysis on this. So what you can do is you can go into analysis here and then hit batch analysis. And then we'll have our 2 airfoils here for our batch analysis. You need to select both of them. And then there's going to be a list of Reynolds numbers here and Mach numbers. This is where you need your list to be really extensive. I put it almost down to 0. It has a little issue with it being at 0 Reynolds number. Obviously, it doesn't exist, so that's has an issue with that. But our Reynolds numbers will start from 47,000 to 97,000. But I made increments of 5,000 all the way through, all the way up to 200,000. So way above, way below the actual Reynolds numbers that we need. And when you do that, it just allows it to interpolate the information and get to the Reynolds number you need when you do the wing analysis. So bigger lists will take a lot longer to run, but it is definitely a better, more accurate analysis when you do that. So again, we're going from alpha here of -8 to 24 in increments of 2. You always really want to check from 0. It gives you more accurate analysis when you do that. And then you would, from there, you would click analyze. This run for these took about 10 minutes, so I'm not going to click that, and that's why I already have it up. So, but when that is all done, I have them all here, but they're not showing on here. But if I go into polars and then show all polars, these lighter pink and lighter blue lines are what the batch analysis will come through as. So you'll see all these, and that's where all the data is going to come from when you do your wing analysis. So once you get that all done, then you can move over to modules here, hit wing and plane design. Again, here's my information. It's all pre-populated. This is going to be completely blank, but what you need to do is actually define 2 planes, one with the NACA 0012 and the NACA 4412. So we're going to create the wings here. You would define a new plane and name it whatever you would like. You're going to deselect elevators and fin. You're going to hit define here. So we're going to define our coordinates, or our characteristics of the actual wing. So these are half wing coordinates. So we're going to start from 0. You give your axis X and Y here and your Z axis, but our Y axis from 0 to 0.076 because the wing is 0.151. So that would be half of that, and it doesn't allow you to go any lower in accuracy here, so it has to be a 6. So we'll go with that. Chord is 0.1. Chord does not change along the whole length of the wing, so it's going to be 0.1 for all that, and we have no offset. So it's a rectangular wing here. And then you would just select which airfoil you wanted, 0012 or 4412. So whatever ones you've already pre-populated before will show up here. Airfoil doesn't change across the whole thing, so as you can see, there's a little diagram here of what it looks like. And then you go ahead and save there, and you would save again. Again, I'm not going to hit save because it'll just populate another wing or try to override it. So, but I'm going to discard that, and you would do that for both the 0012 and the 4412. So once you get both of those planes made, then you can go in, you would select which one you want it to do an analysis on. Then you click analysis, define an analysis. So this is always going to be a type 1 fixed speed analysis. We have two different free stream velocities here, 14.5622, and the other one we used was 7.0952, and those are what we used in the lab portion. So we wanted to match those. The other thing you need to do is you need to go to analysis, and because of the low aspect ratio, we can't do a LLT. We have to do the VLM actual analysis here. So you select VLM 1, and then on those you would hit save, and you would need to do that for both velocities and both wings. So you end up with 4 different analyses, and they would show up like these. And then from there, again, it's just like with the airfoil here, you run from 0 to 24 and 0 to -8 at the increments of 2 is what we needed for the project. And you do that on all 4 of these here. So, and again, these graphs here, just going to be generic, but you need to double click on them, set up which axes you want to actually use. So this one's CL alpha, or yeah, CL alpha, and then we got CD alpha, CLCD, and then also CLCD versus alpha. So those are those graphs. For the project, we also needed to export them to Excel, and you would just right click on these on your graph, current graph, and then export. It comes out as a CSV, and then you go into Excel and actually work them through Excel. But that's how we got all of this, and thank you for your time.